So one of the things we're going to do to monitor a system, whether it's running Linux or Windows or anything else for that matter, we want to keep track of the processes that are running on it, and we want to be able to manage those processes. Now, in Windows, we'll use Control Alt Delete, and we'll use Task Manager to do that, or other way of starting Task Manager. Um, in Linux, we use the command ps. So ps, get to the right window, stands for process. Now, when I run this ps command, it only gives me two processes. And I've got the process ID, the TTY terminal, the time, and that's the amount of CPU time it's actually used. So that's not the time it's been up. It's the amount of CPU time that's actually been used. And then the actual command that was executed. So you see, I've got bash and I've got ps, which is a process that I just ran to get my list of processes. But notice it's also only showing me processes for me. Now, I'm going to go ahead and add another process here. So I'm going to open up Nano and I'm going to do it in the background. And now when I do ps, it's going to show that process for me. And it shows me that I have one that stopped. And so you'll see right here, my nano process has a process ID of 25416. Okay, cool. Now, that gives me my processes. But what if I want to look at other people's processes? Well, there's a lot of options here for a process, and we're going to look at the most common parameters we use for this, but I want to show you where they all are. So I'm going to do ps dash dash help. If you do dash h, it actually won't find it. But if you do dash dash help, so a lot of Linux commands, if you use dash h, it'll give you help. If not, you can use dash dash h, and it will normally give you what you want. You can also do man ps, and that'll pull up the manual pages. And then Q to quit. That actually gives you a ton more information. So if you're wanting to explore command in detail, using those manual pages can be very helpful. In fact, let me go back in there just for a second, and then I can scroll down, scroll back up, page down, page up, and you'll see it gives you a ton of information on using that and what it does. All right, so I'm going to quit out of there and clear my screen here. Let's go back to ps dash dash help, and this says we can add in an additional thing like simple list output or SLO. So I'm going to do S for simple. That's going to give me some basic options. If I want to know more, I can do dash L, which will give me some more options. And these are quick ways of getting help without having to go through the entirety of the man pages. Okay, common things that we'll use here. Dash A is going to give you everybody. Notice you have dash A or just A. So I can do ps dash A or ps A, and it'll give me kind of the same thing. Not really. So A is going to give me these more options, right? So ps dash A gave me basically my processes. This one gave me a few more. And I don't have the username here. So if I want to know what the username is, I'm going to do a U. And that will show me a bunch of things here, like the username. And now notice I'm seeing my processes and I'm seeing root processes. And then it's also going to give me right here in this column, you'll see the percent of CPU time, the percent of memory usage, the VTY that it's on, the status, the start time, how long it's running. And notice it's now giving me a little bit more of a command. So here, when I did ps-a, ps-a, it just identified the process as ps. On these last two, when I did the A without the dash, it actually gives me my full command line. But I'm still only seeing things that are associated with a TTY. And if this is anything like a Windows system, I know there's got to be a lot more background processes running. So the way I'm going to view that is ps-aux. And that's going to give me all processes, whether they're associated with a TTY terminal or not. And so here you'll see all of these processes that have a question mark for the TTY terminal. Okay. So now I can see all of my processes that running on my system at any given moment. Now, if I want to look for, and you can see there's a lot of them, right? Let's do this, pipe it to more, and you'll see I've got, multiple pages, around about 4 pages of processes there. Okay, let's say I'm looking for a specific process. Well, for that, I can use our good old friendly grep command. So I'm going to do PSAUX, and instead of typing it to more, I'm going to type it to grep, and I'm going to look for the word nano. And that's going to identify for me that one process. Okay, so now I can look at all of my processes. I can also look at specific processes. Now, one of the things that we are going to do on a regular basis is we're going to look for processes that are using a lot of processor time or memory time. And for that, let me do this without my grep, and I'm going to do it without the X. Whoops. Because I want to be able to see these headers. So you can see here I've got %CPU, %mem. So what I can do is I can sort by those particular values. So let me do PS AUX because I want to see everything. I want to do a -- sort equals negative PCPU. Now, what that does is that sorts by %CPU in descending order. So I run the command. I think it worked, but I really don't know because everything scrolled off the screen. So I am going to pipe that to more. And now I get to look at my %CPU time in this column right here. And sure enough, I have 0.4, 0.1, and then everything is 0. So it did it. It did it in %CPU in descending order. Now I can do the same thing for memory. I just change PCPU to PMEM. And I'll sort it again in descending order. And you see I've got from this column right here, 1.8, 0.8, 0.4, 0.3. Okay, so it's just sorting in descending order. Perfect. Now, the only problem is I have a bunch of things and I'm having to pipe that to more to be able to see, the top 5, top 10, whatever. Okay, what happens if I want to only say view the top 5? So what I can do is instead of piping that to more, I can pipe that to a command called head, which will take a look at a string of output like grep, right? Grep looks at a string of output from a command and filters it. Head looks at a string of output and just gives me the top number. So I want the top 5. You can also do N5, or in this version, you can do just -5. And this will give me my top 5 lines from that output. Now notice I've got, user 1, 2, 3, 4 processes. It gave me the top 5 lines. And that's a key thing to look at here. Let me look at my top 2. This just gives me my top 2 lines. First one is the header. So if I want to see my top 5 processes, just a little bit of an idiosyncrasy, I've got to view the top 6 lines. Now, these right here are basically a continuation. So the line is defined by a carriage return at the end. And so at the end of this line, there's a carriage return. At the end of this line, there's not. And you can see how it just rolls over to the next line. But at the end of here, -- wait for a signal, there's a carriage return. So that's what defines it as a line. So by turning the top 6 lines, I get my header and 1, 2, 3, 4, 5 processes. Do the same thing with %CPU. I'm going to change that to CPU, but this time instead of looking at the first 6, I want to view the first 10, which means I'm going to have to set my header to 11. To make sure that I get my header and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 processes. Okay, now what about killing a process? So we have this nice little function here called kill. And the purpose of kill is to stop a particular process. Now, before I do this, let me create another process here that I'm going to put in the background. Whoops, I did $sign instead of, so Control Z will put it in the background, and then another nano process in the background. So now if I look at jobs, I should have multiple processes. Okay. Now, if I do my PS AUX, that'll give me all of my processes, including my nano processes and my VI. And I can actually see them here, right? Or I can use my grep if I want to filter down to those processes. So I'm going to do grep nano, and I'm going to find my nano. Notice, by the way, one of those is grep, which is doing a search for nano. Okay. Now, actually, let me do VI. I want to look at VI first because I want to show you two different kill commands here. So VI, I find my process. Also notice the grep, found everything by David because it has VI in the middle. But this is the one that I want. It's 26110. So my command is kill 26110. And that should kill that process. So let me do PS AUX. And lo and behold, it did not kill 26110. Now, there is another way to do it. You can do a kill dash, I believe it's -9, 26110, which is a little more dramatic of a kill process. And now it says it actually killed it. So that sends that kill signal. And, so kill -9 sends that kill signal, which stops the process. Okay. Now, if I do a PSAUX grep VI, notice I have looking over here into commands, I have nothing there. Now, there is another one, kills by process ID. There is another variation of the command. It's called kill all. So kill all is will kill by name. So let's grep nano here, and you'll see I have multiple versions of nano open. So I'm going to do kill all nano. And let's see if it worked. And it did not. Now, key thing here. So kill sends a kill command, and it's technically it's sigterm, which is a signal to terminate the application. Now, sometimes that terminate the application doesn't actually terminate it. It attempts to shut it down gracefully. And if there's something that's stopping it from shutting down gracefully, and that could be a problem, the processes run amok, or in my text editor, it could be that it's asking me, hey, do you want to save your work here before you shut down? So there's a variety of reasons it could be causing it. The kill -9, or in this case, kill all -9, sends a sig kill, or a kill signal, which is basically pulling the rug out from under it. So I'm going to kill all nano. Now, here's one thing you got to realize. When we do that, it kills everything. It kills by name, but it kills everything by that name. With the just straight kill command, I can't give it a name. I give it a process ID, and it will kill that process ID. So if I wanted to kill one nano but not the other, then I would use a kill. If I want to kill all of them, then I use kill all, specify the name. Okay, so that is how we will review processes, see what they're using resource-wise, and how we can terminate them.